Welcome to our tutorial of ProfLearn YouTube channel. In this particular video, we are going to look at a discussion of some of the questions that have been tested in previous years. And in this case, we're going to look at question 1 of May-June 2025. That is variant 3 of Cambridge 0625. So if you're going to take the May-June exam of 2026, May-June exams of 2027, then this video is for you. Let's dive in so that we can be able to see what are the main questions that are usually asked and how are you supposed to approach them, because so you realize that most of the questions that are usually asked, especially for motion graphs, they are actually repeated now and again. So in this case, let's see the first question. The first question, the student was supposed to determine, the student was asked to determine what? The student was asked to determine the speed of the car at t is equals to 2.0 seconds. So what that means is that you are going to check where you have 2 seconds, you draw a straight line and you check where that straight line is going to meet the graph, and then you draw a horizontal line at that point. You check which reading is here, and in this case, when you check the reading, you are going to get that the value of the speed at that given point is basically 11.5 meters per second. So from the graph, if you are asked to find the speed, because this is a speed time graph, then it means that you can be able to redirect by just checking that particular time that you are being told. For instance, here we are being told the time of 2 seconds. So you move up and you check the reading that is at a given point. And if you can be able to check that, you realize that the correct answer here was supposed to be 11.5 meters per second. Now, besides that, you may be asked to work out the distance traveled from a velocity time graph, from a distance time graph. So something here you need to realize and understand is that from this kind of graphs, you can be able to get. So if you are finding the distance covered from the graph, what you're going to do here is to work out the area. Distance covered or distance traveled, you're going to find the area under the graph. So meaning that if you have a graph like this and you are told to find a particular distance from a given time to another time, for instance here from 0 to 4 seconds, we are going to work out the area of the shape of the graph. And this is going to be, this is a rectangle. I'll find the area of the rectangle, I call that A, and the area of the triangle, which I called B. So when I worked out the area of the first part was, I used the length times width, because this is the shape of a rectangle. And for the triangle, I used a half base times height. And then when I worked it out, I got my answer as 45 meters. So something that you must understand, if you are given distance time graph, velocity time graph, if you are being asked to work out the distance covered, distance traveled, just work out the total area under the graph. Once you have gotten that, you may be asked to work out acceleration or deceleration. In that case, you need to remember that acceleration or deceleration is equal to the gradient of a speed time graph. And at the same point, you remember the formula for acceleration is final velocity minus initial velocity over time taken. So in this case, if we are finding deceleration in the from 0.5 to 4, this will be, this velocity that we will have here will be our initial velocity. Final velocity will be 0, because at this point correspond to a velocity of 0 at that point. So that's going to be final minus initial. So there's going to be 0 is the final minus 20, which is the initial velocity, and time is 4 minus 0.5. If you work it out, you are going to get your answer being equivalent to 5.7 meter per second square. So don't forget to include the units, because they were not included here, they were not written here, so which means that you must indicate or include the units at that given point. All right, so moving further to the next concept that was tested here is the concept of momentum. So you were supposed to understand that momentum is equals to mass times velocity. So this question, you are supposed to show the momentum was that. So meaning that the capsule, we need to know the mass of the capsule. And in this case, in this space vehicle, it had a mass of 840. And it was moving at this velocity. So meaning that we can be able to get momentum using the formula that I've highlighted here. And if you work it out, it will be 6.55 times 10 to the power 6. Once you've done that, the next question was to determine the velocity of the capsule after the cone has been ejected. So meaning that we need to use the law of conservation of momentum, which is total momentum before is equal to total momentum after. So in this case, we have gotten the total momentum before, which was this value that we have here. But after, mass was 720, it was moving at a given velocity, which we don't know. And then the mass of the other part, cone that was ejected, was 120, but it was moving at 850. Both of them are moving the same direction. So we can say 720 times v, because 720 times the speed which we are looking for, plus 120 times 850, but must be equals to the initial total momentum that was there. So if you try to work out v, you will take this value on the other side of the equal sign, divide by 720, you will get your final answer to be 7790, correct to 3 significant figures, because in this question we were told to give our answer in 3 SF. And the next part was talking about terminal velocity. You need to understand that an object will move at terminal velocity when upward forces and downward forces are balanced. So if the upward force equals to the downward force, then it means there is no resultant force, and that will mean that the object will be moving at terminal velocity. So in that case, so we are going to say that if this object was moving at terminal velocity and the upward vertical force was 120, then you need to remember that this object will be, there are forces acting on it. There will be downward force, which is the weight of the capsule, and also there will be upward force, and the upward force could be drag or air resistance, or upthrust force. So all those forces that were upward were equal to 120 Newton. And since it was moving at terminal velocity, it means also the weight of this object is equal to 120,000 Newtons. And that is why now I used 120,000 Newtons as the weight in this case. Now for me to find the mass, I can be able to say mass is weight divided by gravity. And when I worked it out, I got my answer being 12,000. That's 12,245. Then now I decided to write it to 3 significant figures as the raw data that was given. So that is exactly what we are supposed to do at that given point. All right, so the next part we are going to look at this archer who is aiming an arrow there. So that is, you check in the description, there is a link for this particular question now that is here. See you in the next video. All the best. If you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. Consider joining our Patreon page so that you can be able to access different PDF I usually include in my videos. If you are new here, don't forget to subscribe, leave a comment if this video was helpful.